Okay, I really want to look at lesson 10 for homework, the equations of circles. Remember, the equation of a circle is x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared, where h and k, that's the center point, and r is the radius. So if I'm looking at number 2, you got the center at 3, 1, and the diameter being 14. So I'm going to write HK because you're given your center and you have the diameter, which if you want to find the radius, you take the diameter and divide by 2. So really this is R equals 7, or the radius is 7. So using my equation, it's x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. So I'm going to replace h and k with 3 and 1, respectively. So I have x minus 3, the quantity squared, plus y minus 1, the quantity squared, equals 7 squared. So I'm going to simplify this equation, and this should be your answer. X minus 3, the quantity squared, plus y minus 1, the quantity squared, equals 49. Number 4, you have the center at -5, 3, and it passes through the point 1, -4. Notice that we have the center given, but we don't have the radius. It says that, okay, we have our circle. It has a center point at -5, 3, and that same circle passes through the point 1, -4. So this is just an ordinary point, which I'm going to call 1x and -4y. So using my equation, again, it's x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. You're going to replace x and y with 1 and -4, respectively, and you're going to replace h and k with -5 and 3, respectively. So you should have 1 minus -5, the quantity squared, plus -4 minus 3 quantity squared equals r squared. And then 1 minus -5 is just 6, right? 1 minus -5, it's 1, that minus and a negative turns into a plus. So it's 6 squared plus -7 quantity squared equals r squared. So 6 squared is 36, and 7 squared is 49. Sorry, -7 quantity squared, which is 49. So I have 36 plus 49. So 36 plus 49 is... Sorry, I gotta figure this out. 36 plus 49 is 85. So r squared is 85. And then look at this. Because we know what h and k are, it's -5 and 3, and we also have r squared, which is 85, I can go ahead and just plug everything in. So your answer, I'm going to put this in red, by the way, it's x minus -5, the quantity squared, plus y minus 3 quantity squared equals 85, because r squared is 85. So this should be x plus 5 quantity squared plus y minus 3, the quantity squared, equals 85, and that should be your answer. Okay? All right. Number 6, this is a picture. You're giving the center, and then you should... Ooh, this one might be a little weird, because the radius is from here to here. So, okay, so what do I do if I'm trying to figure out the radius? Well, it's if you're because we're so used because you first of all, what I'm trying to say is okay, you have the center point and it's going to this point because it's given, but it's really, really difficult to figure out how long this length here is without performing basically this. What this is trying to say is you have the center at 3 comma negative 4 that passes through 0 comma negative 6. So this is basically this example but in picture form. So you're going to use this hint that I'm going to give you and you're going to perform something similar to what I have for number 4. Okay? Number 8. Okay, so all you have to do is just identify what the center here is and what is the radius, and then go ahead and just draw the figure. Okay, 14, 15. Okay, let's look at 16 together. It says center at 8 comma negative 9, and the radius is the square root of 11. So it should be x. So this is h, k, and your radius is the square root of 11, right? So you have x minus 8 quantity squared plus y minus negative 9 the quantity squared equals root 11 squared. In parentheses, by the way. So you have x minus 8 the quantity squared plus y plus 9 the quantity squared is equal to, well, root 11 squared, or root 11 the quantity squared, is basically root 11 times root 11. So that's just 11, and that's your answer, okay? Number 18 is just like these problems, and number 20 is like number 6, it seems like. So I think you're in good hands. For each circle with the given equation, state the coordinates of the center and the measure of the radius. Okay, that should be very, very simple because you have your center and you have your radius just by looking at this equation, and that's the same thing for number 24. Number 29 and number 31. It looks like you're going to have to apply. You're gonna have to draw the figure, and then you're just going to have to apply the system of equations, okay? So you should definitely go back to the notes or the notes video, look at that so you have an idea on what to do. I'm thinking that I'm just going to look at number 31, which is x squared plus the quantity y plus 2, x squared plus y plus 2, the quantity squared equals 8. And you have y equals x minus 2. So let's go ahead and figure everything out. So let's graph this equation here. The center is 0 comma negative 2, and the radius, well, currently this is r squared, right? So this is r squared because it's x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared, and 8 is taking the position of r squared. So r squared is currently 8. So I can just do this. I can do r squared equals 8, and I'm going to take the square root of 8. The square root of 8 is 2.8. So r is 2.8. So then let's graph the center. So 0 comma negative 2 is right here, and I'm going to go up 2.8. So 1, 2, that's 2.8. That's 2.8. Let's see, this is 2.8. And then that's 2.8. And then here's my circle. This is This is the equation in blue. I'm going to go ahead and graph the equation in pink, which I'm going to use, red when I'm graphing, actually. So y equals x minus 2, that's in the form y equals mx plus b. So your slope is 1 and your y-intercept is negative 2. So I should start at negative 2. And I'm going to go up 1, right 1, up 1, right 1, and so on and so forth. Okay, so this is what I'm graphing here. So now what I'm going to do is, okay, I can see that in terms of intersections, they intersect here and here. And it does look like it intersects exactly at a point here and here, but I'm not sure because I could mess up on the drawing or something like that. I have to verify by just plugging things in or just use a system of equations. So note that y is equal to x minus 2, the quantity squared, okay? So if y is equal to x minus 2, well, y'all, look, y is right here. So I can take this equation and replace y with that. So I have x squared plus x minus 2 plus 2 quantity squared equals 8. And then, oh, look at that. I have negative 2 plus 2 inside of the parentheses, so I can just remove that. I can chuck that away. So I have x squared plus x squared, which is equal to 8. Note that I have two x squares. So 2x squared equals 8. Divide both sides by 2. X squared is equal to 4. So if I take the square root, I have x equals 2. Actually, x equals plus or minus 2. Okay? So these points here are in the form x comma y. These points here are in the form x comma y. So if I plug in positive 2 and I'm looking for y, well, positive 2 minus 2 is 0. That's one of my points. It should be right here. And the other point, this point here, it's negative 2 because x can be also be negative 2. So it's negative 2 comma y equals negative 2 minus 2. That's negative 4. And there you go. Those are the points of intersections. All right, and then I'm going to let you be with 53, 54, and 55, okay? So there you go. That's the homework help video. Oh, I just want to look at number 29 real quickly. It says we have two equations, and we need to find the points of intersection. One of the equations is x squared plus y squared equals 5, and the other equation is y equals 1/2 x. Now, in class, we were able to plug things in easily because we had a variable equal to some sort of, whole number or whatever. But this time, we have a variable equal to a fraction. So y is equal to 1/2 x. So, okay, you would think you would plug this into this, which you can do. But the problem here is that once you replace y with 1/2 x squared, you have to distribute the exponent of 2 to the numerator and the denominator, and also to the x, and simplify everything. And that's a lot of work. And after that, once you get, that done, you have to combine that with x squared, and you have to, add a whole number with a fraction, and you have to use some sort of method there, which takes time. It's not that hard, but let's just make your life easier. I have y equals 1/2 x. I'm going to manipulate this equation, okay? So y equals 1/2 x. I can rewrite this as y equals x over 2. Okay, 1/2 x is, or sorry, yeah, 1/2 x is the same thing as x over 2. So now that I have y equals x over 2, I'm going to get x by itself. Note that we have that 2 in the denominator, so I need to multiply both sides of the equation by 2. So let's cancel the 2 2's. So I have 2y equals x, okay? So x is 2y. That means that I don't need to use this anymore. That y equals 1/2 x, that can go away. Because this becomes this now. So I'm working with the old equation and this new equation. Okay? All right. So the fact that we know that x is equal to 2y, right? So x is equal to 2y. Here's x. I'm going to replace that x with 2y. And remember, when we're replacing variables, use your parentheses. So it's 2y, the quantity squared, plus y squared equals 5. And then when you see something like this, you're like, oh, okay, I can just do 2y squared plus y squared, which is 3y squared. No, you can't do that. And the reason being is this 2y, the quantity squared, okay? 2y, the quantity squared, is essentially 2y times 2y. So using our rules of exponents, or one of the rules there, since I have this type of expression raised to the second power, I have to distribute the exponent of 2 to the 2 in the fraction, or sorry, not in the fraction, in the parentheses, and the y in the parentheses. So it's 2 squared times y squared, which is 4y squared. Okay, so 2y, the quantity squared, is 4y squared. Then we have plus y squared equals 5, and there you go. You have 4y squared plus y squared equals 5. You can combine the like terms, do the algebra, and then do the rest of the problem. Find the point of intersection. Okay, so there you go. All right, number 55, this is what is the equation of the circle that passes through 0, -2, 8, -2, and 4, -6. What I recommend that you do for this problem here is use Desmos. Desmos graphing calculator. Once you're on Desmos, plot those points. Plug in those points, 0, -2, 8, -2, 4, -6, and then look at that graph, and hopefully that will get you started. Just imagine that there's a circle there. What's the radius? What's the center? You should know how the center works. You should know how the radius works. So use that Desmos to help you answer number 55, okay?